The 2025 Nobel Prize in Physics has been awarded to John Clarke, Michel Devoret and John Martinis for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. They showed that even large systems can behave like atoms, passing through energy barriers. In other words, the scientists brought quantum mechanics into the visible world, and in this video we'll tell you about their discovery. There's a boundary humanity has always tried to cross between the macroscopic world, which we can observe with the naked eye, and the microscopic world, where the laws of classic physics no longer apply. In quantum realm, particles can exist everywhere at once. For a long time, it was believed that this strange world belonged only to atoms and photons, far beyond the reach of our instruments. But in the mid-80s, in the University of California in Berkeley, physicists John Clarke, Michel Devoret and John Martinis built a tiny electrical circuit just 1 centimeter wide. It was made of superconductors, materials in which electrons form synchronized pairs known as Cooper pairs. These pairs don't collide with atoms and lose no energy, allowing them to glide through the material without resistance. This phenomenon is called superconductivity. To test the limits of this effect, the researchers inserted a thin, non-conducting layer between two superconductors, creating a Josephson junction, a kind of bridge through which quantum effects can emerge. And here's where things get fascinating. In classical physics, if you throw a ball at a wall, it always bounces back. But in the quantum world, the wall might simply stop being an obstacle. This process, known as quantum tunneling, had only ever been observed in single particles, until our laureates saw it happened in a macroscopic system. Their circuit, initially in a zero-voltage state, suddenly tunneled through an energy barrier, and a voltage appeared where none should exist. The system seemed to switch itself from off to on, despite the barrier. But the surprises didn't stop there. When the researchers exposed the circuit to microwaves, they noticed that it absorbed only specific frequencies, jumping to higher energy levels. And tunneling became easier at these high levels, perfectly matching the predictions of quantum mechanics. In other words, the scientists confirmed that the macroscopic system was quantized. It could absorb or emit energy only in specific, discrete amounts, quanta. For the first time in history, this was demonstrated not with a single atom or electron, but with an entire system. One of the laureates, John Martinis, later used the principle of energy quantization to create the first practical quantum bits, qubits, the foundation of modern quantum computers. John Clarke, Michel Devoret and John Martinis fundamentally changed the scale of quantum mechanics, proving that the universe doesn't draw a strict line between the micro and the macro worlds. This discovery not only brings us closer to better quantum computers, it also invites us to see reality from a new perspective. An incredible achievement. Congratulations to the laureates. And please tell us in the comments what impressed you most. And subscribe if science inspires you as much as it does us. And see you in the next video.